First, like always, the problem is asking us to find a domain. A domain of this function, because of the arrows, it's definitely everything. Then we're asked to find the range. So remember, for the domain, we sweep the graph from left to right. Everything. Nothing is missing. For the range, we sweep from below to above. I'm not really sure if this appears to be, let me see if I can enlarge this. If it appears to be -3 or -4, I'm not sure. I think it's -3, but I'm going to... What do you see? As I said, my...
-4.
Is it -4? It appears to be -4?
Yes.
Okay, I was able to enlarge it now. Yes, I think it is -4. So my graph is not perfect here. So I'm going to say this. This was 3 here. So this is -4. So I'm going to say from a bracket, a -4 to infinity. Then we're asked to find the x-intercepts. So the x-intercepts, according to what I saw initially, 1, 2, 3, 4, 5, 6, 7. So I see the x-intercepts 3, 0, and 7, 0. X-intercepts. Let's see. The y-intercept, I see it 18, 19, 20, 21, 2, 3, 4. Yes, I think if the y-intercept is 0, 21. Do you see that like I do?
Yeah.
Okay. Intervals on which f is increasing. So just follow the graph. Constant, decreasing, increasing. But remember, we are asked not from which value to which value. We're asked about the interval on which the function is increasing. So then the function appears to be increasing from x equals 5, from x equals 5 till x equals infinity. So I see 6 and 5, yes. 5 to infinity, the function is increasing. So I will write f increasing on the interval 5 to infinity for x. Intervals for which f is decreasing. F is decreasing from 0 for x, till 5 for x. From 0 to 5 for x. 0 to 5. Then intervals on which f is constant. F constant for which x values? From -infinity to 0. -infinity to 0, the function is constant. On -infinity to 0. Notice that all these are open intervals, parentheses, not brackets. The number at which f has a relative minimum. F has a relative min at x equals 5. Right here. The number at which f has a relative minimum. So this is h. The relative minimum, I, is asking us for the y value. F's min is -4. F's min is -4. That's the y value. F of -6. For f of -6, I have to draw a vertical line. Draw x equals -6. So here it is. 1, 2, 3, 4, 5, 6. You don't really have to draw it, but at least imagine you draw it. It crosses the function in one point, and I will be reading that 21. So this is 21. Which point we read from? -6, 21. the values of x for which f of x equals -3. Any questions so far? So f of x equals -3 really means y equals -3, which is the altitude. So, -3. 1, 2, 3. So I don't want to get to 4. So I will draw, or imagine I draw a horizontal line y equals -3. Sorry. Let me write it again. -3, so it's clear. So y equals -3. I see it crosses the graph in 2 points. And at those 2 points, I have to read the x value. On my graph, it appears to be 4 and 6. I'm not sure about the graph over there. I think it is. So x equals 4 and x equals 6. I can present on my paper, with my work, I can write 4 comma -3. This is one point that I read from, and 6 comma -3. And final question, is f even, odd, or none of the above? Of course it's not symmetric. Why is not symmetric? Because symmetry requires that to have the same graph on both sides of the y-axis, which is not the case, or have the same graph across the origin, which is not the case. So it cannot be odd for the origin, and it cannot be even for the y-axis. So the function is not symmetric. Any questions? And let's graph 16. So the function is, I will not select a function with quadratics. We haven't discussed in detail quadratics, but let's talk about this one. In chapter 3, we're going to start with the quadratic function. So we're going to have plenty of time to discuss the quadratic function again and again. So, first of all, I change this into -∞ to 2. Then I change this into 2 to infinity because I want to identify the domain first. That is always my first thought. When I'm asked to graph a function, that is my first thought. Any questions? Okay, so I noticed that it's all real numbers. And at this point, I realize that 2 is a very important x value. The function changes from a quadratic to a linear at 2. So -∞, 0, 2, and infinity. So at 2, I will copy the symbols that I see here for the intervals. And they are touching. The left is a parenthesis, the right is a bracket. Exactly how I see them here. To the left, facing -1. To the right, a bracket facing infinity. An overkill, I know. I want to see it here. And greater than 2 to infinity, I want to see it here. Now I plug in some values on the left. For example, -1. Or maybe it's even better, -2, because it's going to be an integer. So -2 squared is 4. 4 divided by 2 will be 2. When I plug in 0, I get 0. When I plug in 2, you should say, no, no, no. You're not allowed to. And I'll say, bear with me. It's 4 divided by 2. It's 2 right here inside the parenthesis. Right inside, I put the 2. Because this will signify 2, comma 2, open point. And on this side, 10 minus 4 is 8 inside the bracket. And let's say 3, 15 minus 4 is 12. And 2, comma 8 will be a full point. 2, comma 8, full point. Okay, so we're ready to graph then. So negative 2, comma 2 is this full point. 0, comma 0 is this full point. But 2, comma 2 will be an open point. You may remember this or not, but this is a quadratic function opening up. We're also going to graph this in transformations, but this previous test had transformations in it, so this function was there, so that's why you see it. See, I graph this in a particular color, and I will graph the other part in a different color just to make sure that you understand that they cannot overlap. So 2, comma 8, 2, 3, 4, 5, 6, 7, 8. So this is a full point. And 3, comma 12 will be further up, so I'm just going to graph this. If I'm asked to find the range, I'll try to sweep the graph from the bottom to above, from 0, yes, 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 yes. So it's 0 to infinity. I've seen it in my calculus class. They had a test on Monday night, and a student graphed this function like the following. And I would like you to tell me what is wrong with it. How come that I cannot graph that function like this? How come that I claim that this is incorrect? How come? This is this function. This is this function. How come that this is incorrect?
Because they have an open and close point. They don't have one.
Furthermore, tell me what I'm doing now. Is this a function? Of course. Not a function. Let's do it now here. Is this a function?
I want to say yes, but I don't know about those 2 points too.
Look, if I draw a vertical line here, how many points do I hit? I'm going to do it in pencil so in case you want to print this out later. How many points do I hit?
2.
Is this a point?
I guess not.
It's not. It's not included. So everywhere this is a function, including here. A full point exists, an open point does not. If I make a mistake, and I'm going to erase that, if I make a mistake and put a full point here, that's not a function. But I didn't. And I couldn't. I'm not allowed to plug in 2 here. That's why I have an open point. Or parenthesis, it's an open point. 2 comma 2 is an open point. It doesn't exist. What I should plug in on this side is 1.9999999999999. I don't want to do that. I would rather plug in 2 and get it as an open point. Is this okay? So please do not make this mistake. Furthermore, this function is only between negative infinity and 2. Cannot extend anywhere else. This function is only between 2 and infinity. You cannot extend it that way. You're not allowed to. Good. Anything else? Are we going to be okay with this test?
Number 21's not on the test, right?
Let me take a look. 21, 21, 21, 21. Of course not. We did not do transformations. As I said, some of you